So we are here right now in the Wema Children Centre main campus. The campus is kind of divided into a couple different sections. So this is the main campus right here. I'm kind of behind the teachers' dormitory building, and it goes all the way out to the north there, kind of northwest, by about, I don't know, a quarter of a mile. It's not really that big of an area. And then up down this road here, going this way, we have Market School, which is also owned by the Wema and Highway Academy, and they kind of manage that. That's where all the preschool to grade 3 go. So here there are many issues that we're trying to solve while here on site, but our most urgent issue right now is dealing with this kind of these areas here. As you can see, it doesn't look like much, but this is actually the site of one of their bathrooms. Back in June, they fell down due to heavy flooding, so this is all that's left. It's really just nothing, just kind of open land for building something else to take its place, and that's kind of what we're trying to do. We're coming up with a design after we leave here, and we're going to work on that design the next couple months and hopefully be able to implement that once we get funding to come in for it.
So this is one of our existing latrines, very typical on site. There's several around. It's the same type as the one that collapsed in that I showed you earlier. But this is still standing at the moment. It's at a higher elevation on site. So I just kind of want to show you what the existing condition is, just to see what we're dealing with. So in this latrine, it's all just toilets. Some have a little wash area, but this is the existing squat latrine. You can see there's a little basin for catching urine, a very small hole to make it into. It's a pretty small and kind of cramped compartment. And I really wish you had some way to scratch and sniff or something, because it smells really bad in here. They're not ventilated in any way. So it's just kind of an overall sanitation issue. And so the sanitation, along with the actual collapse of these latrines, means that we are going to be looking to just replace these outright with modern structures with flush toilets. So no longer have to use these.
So one of the big factors that we need to figure out when we're here, we need to test for drawdown.
This is a double ring infiltrometer. It basically is measuring how fast water drains into the soil. Depending on what your soil is like, it could be like sand or clay, water will drain in at different speeds. And since we're building new bathrooms and we have to dispose of the waste deep underground, we need to measure how fast that water will push itself down into the ground below.
This area is experiencing some real water shortage issues, and that'll be something that we might have to deal with in the future, or prepare, make preparations now for any new infrastructure that gets put in, because it could be some time before this region experiences the rainfall that's been known to occur here during the rainy seasons. We've started a pilot of rainwater. Rainwater harvesting is something that they've acknowledged that they can use, and we're starting to make that evaluation, putting in a pilot test, just to check in with them in the future to see how it's doing, how much water they're actually getting, and if the gutter system is working, and so on and so forth.
Hey, I'm Joe, here with Chicago Engineers Without Borders. We're up behind the dining hall at the Wema Children Centre. We got the kitchen up here to my left. What we put up is a rainwater catchment system. So it appears to be a fairly simple gutter, but there are some specifics involved we looked into. We had a couple trips to Bukembe a big city close by to see what materials are available. We have an existing truss system in the building. We put on some simple extensions, some fascia boards, these 1x8 pieces of wood, which we primed and sealed with paint. Then we used the bracket and gutter system all the way down with a slight slope downward. So what this does is catches the rainwater into our tank down at the end. This is our first pilot system, and we're going to see a couple of the components and how they work, and if we want to replace some parts next time around. If you come closer to the tank with me, here we have our tank. It's being fed from an inlet on the opposite side here. There's a first flush pipe. What this does is catches the initial dust and debris and biological excrement that comes from that initial downslope from the rain. We're going to test how this works and make modifications as necessary. We do have a trench that was dug through here. This is where a lot of the water is going to drain from an overflow valve and that first catch as it gradually trickles through. We do plan to have concrete slabs under the tanks. We will have those put in at a later time. We have a spigot and hose on the other side. And we had some help here from a local laborer craftsman, Lawrence, and we're counting on him to help us assess this design, possibly put in future rainwater catchment systems for us. We trust him because he's proven to be skilled with woodworking, general plumbing, and he has a familiarity with the site. He's friends with the owners. So what this water is going to be used for is a variety of non-potable sources. We have a latrine system behind us. It could be used for hand washing. We could also use it for, washing clothes, general other non-potable sources or uses. But long term, we could consider treating this water using pumps to add it to a potable water system.
And the house was also catching fire. We had to do a lot of work to put on the electric fire using mud and sand. You can see these are the remains of the mud that we were using and the sand. The equipment burned so much, the old box went. This is a new thing that we just put in recently, the fuse. Everything in the meter box burned. And these are the remnants. Yeah.
We've been here since April 2nd, and it's now April 8th. We have not had a third phase of power since we arrived. The way we measured that was through the utilities box here. Through voltage readings from our solar mentor, Caro Fernandez, and our electrical engineer, Jorge Marquez, we determined that we have 2 phases of power, which is intermittent, allowing other loads on the facility to be powered, but not our 3-phase pump. This is the water kiosk. It has the water tank up top, and in here you'll see the chlorinator and filtration system that the team in 2017 installed. Looking through some electrical panels right up here, we encountered a safety hazard from local electricians trying to fix things but not having the proper training and no help at all whatsoever from the utility. Kenya Power, the local utility, has been contacted several times since we've been on site. They claim to have fixed the issue, however, our pump is still not running. What that means is that everyone's going down to the river, Springbox, other wells in the area to get water that's not going through our filtration system. So we've identified this as a critical need for the project. We are designing a solar system for that need, and we met with contractors on site to try to determine the best way forward.
So we have a lot of work to do still. A lot of design work to do when we get back, but I think it'll go pretty quickly. I think the needs are very clear here, and we can communicate that to our members when we get back, and we can have dedicated teams to continue with this work.
The engineers who go all over the world, and that is why they are here. They are going to help us improve on our water, improve on sanitation, and then on our energy. Are you happy? Yes.